So let's go into what exactly is Industry 4.0 and why did we come and how did we come to Industry 4.0. So initially you had horse-drawn carts that was replaced by steam engines through various sorts of mechanization. You had water, steam power, hydropower, and you had different manufacturing methods. Iron was starting to be produced from the mines and various tier 3 companies. Your textile industry was booming, spinning mill was introduced, mining and metallurgy took really the driver's seat. And you also had machine tools and all the factories run by steam. Now we move on to the second revolution, wherein you had a lot of electrification, lot of electrical things came into the picture to help the workers in achieving their targets and improving their targets and accuracy of the products. Henry Ford established the production line and the assembly line system for automobiles. Products were being produced in mass production levels. Globalization occurred. You had various internal combustion engines and gas turbines. And there was broad adoption of telegraph, which means communication was very easy. And then finally, you had gas and water supply. Now we move on to our decade, wherein it is Industry 3. You have the internet, you have the computer, everything controlled using the computer and the internet. You have digital manufacturing, wherein you have CNC machines which run on a set of preset codes, and the operator just has to check whether the operation has been done correctly and, as always, input the codes and check for any errors in the codes. And you have a lot of PLC and robotics which come into place. You have digitization, automation, which means the tasks are done automatically, albeit with limited human interaction. You have various electronic and digital networks to monitor things, and you finally have digital machines. Now, one key thing about this, one key element which is missing, which was really thrown to light because of the pandemic we have. When the pandemic came into place, everybody, all factories were on lockdown. You could not do anything. You could not step out of your house. You couldn't go to work. Nothing was being produced. Commerce wasn't happening. No cars were being built. No factories were being run. So what happened to the economy? The economy came to a standstill. But then, if you had automated machines, if you had advanced robotics like you have in Industry 4.0, you could have might as well run the factories because there was no humans in the factories. You could happily work from home and start your factory, say 100, 200 kilometers away through the internet. Also, with this level of advanced robotics machinery, you can monitor each and everything. For example, if you take the automobile production line, you have to weld two panels together, say your front door to the chassis of the car, to the frame of the car. So how do you tell your machine that you have to keep the machine in this sort of an angle and weld it in a particular direction, and you must have 4 welds on the car? So all this can be achieved through sensors. So first the machine should know what it is. It should know what position it is in. It should know what to weld and where to weld and how to weld it. Also, there should be another machine or the same machine monitoring the progress of this machine. So suppose you have 4 doors, you have 2 machines each, or you can have 4 doors, 4 machines for each door, or sorry, 4 machines for 4 doors, and 1 machine monitoring the progress. So you can monitor the results from this and also analyze the accuracy and quality of this. Plus, since we have a lot of machines, we'll be gathering a lot of data. So all the data can be analyzed and you can get potential risks which you might get from the machines, or you can also improve the process. Again, all this is possible only through artificial intelligence, machine learning, and Internet of Things. So your machines should be like a smartphone, like the smartphone you have, which monitors a lot of parameters, which has a lot of sensors, and which tells you immediately. Suppose you want to know what the spelling of India is. You just say, "Hey Google, tell me the spelling of India." So it tells you. So how did the smartphone know? It's connected to the internet, and it's connected to Google. Google is a search engine. You will get thousands of results of data on Google. So your phone should know what you're asking for, what result it has to search in, and also it has to relay that result to the customer. This is the simplest introduction or simplest explanation you could give for IoT and AI. Basically, Industry 4.0 focuses on the entire process. That is, from scratch. You want a car, you design a car, you see how can you manufacture the car, finally how do you deliver the car to the end customer. This is your process, three-step process: design, manufacture, deliver. Now you have to see how you can automate this process. Through Industry 4.0, you can automate the process. You can simulate. We will see in the next slide. Yeah. So, using, if you could see the bottom left-hand corner, simulate. You can simulate your design. You can simulate the design of the body. You can do analysis of it using various computer-aided design CAD softwares. You can analyze the wind flow over the car. You can analyze the heat. You can analyze the crash using finite element analysis. All this can be done while from the comfort of your own home. So all the data can be processed, and the computer can tell you which design would be the most favorable to meet all your regulations. And how is this possible? You must have a physical mock-up at the factory, and your system should also scan the mock-up of the car at the factory, and then your laptop or your computer should coexist with the scanner at the factory. So your systems should integrate. There should be seamless integration. Plus, all your data has to be stored in one particular place, at say a data center. So how is this possible? This is possible through cloud computing. So whatever you do on your laptop is visible on your mobile phone, is visible on your manufacturing machine, is visible on your scanner at the factory. Again, how is this possible? Through Internet of Things? But there is one risk. Suppose your laptop is stolen, God forbid. Somebody steals your laptop. What do you do? So unless they have your fingerprint or your physical key password, they cannot steal your information. Which is why cybersecurity plays a huge role in Industry 4.0. You must have heard about, say, blockchain technology, which is very important for uh, cybersecurity. It is most essential in these times. Coming back to the design phase, suppose you want to create a brand new product which nobody is designed before. You, without going to say an expensive factory, especially in these times, you want to visualize the product. How can you visualize the product? You can use something called augmented reality and virtual reality. I hope all of you play video games, so they might have you might have kept a controller over your head, the like the Google Cardboard or Oculus Rift controller, and you can play the games in virtual reality. Most automakers also launch their cars online nowadays through OTT platforms. And you can also visualize the car using augmented reality. When you have time, I would like you to check out, say, Tata Motors Safari. In Twitter, they have launched an AR platform, augmented reality platform, wherein using your mobile phone, you can see the whole car. You can see the cars outside, you can see the cars inside, the engine, you can open the door, you can open the bonnet, you can see a very nice mock-up model of the car without going to a showroom from the comfort and safety of your own home. So again, all this is possible through data. Everything, since everything is electronic and everything is monitored, you have data. So you can use the data. How can you use the data? You can analyze, see how many people attended your lecture, how many people attended your online unveiling of the car, how many people have booked a car using your online unveil, how many people have finally gotten delivery of their car through online. So all these sorts of data analytics you can perform with big data. So you can also check in your factories in manufacturing for autonomous robots, wherein it will be difficult and not difficult per se. It would be unsafe for a human being to go and perform certain actions of a car. See, painting a car is a very dangerous process. You need the proper personal protective equipment. You need a rebreather. You need oxygen. You need eye protection. You have to protect your hair. You have to wear gloves to prevent splashes because everything is carcinogenous nowadays. So in these painting sort of scenarios, just like the painting sort of scenarios, you will have a lot of places where a human being cannot be endangered. Human life is very important. So which is why you have autonomous robots. You program a robot to paint a car in this fashion, it will do what it's told. It will paint the car in with the utmost quality and accuracy. Additive manufacturing is another thing. You might have heard about 3D printing, wherein you use a printer, a normal printer, with a special jet and special plastic material, which makes a small model of anything which you program into, just a CAD model, from the bottom to top. So, what can you use this for? You can use it for parts which are very difficult to manufacture using various other sources. You can use it for parts for vehicles which aren't produced anymore. Or even small parts for, say, mobile phones. You can 3D print a whole mobile phone using a 3D printer. Apart from certain things like a battery and as the screen. So these are the various things which help out various components of Industry 4.0. Okay, now how do you implement it? You have sensors and actuators. From the bottom of the pyramid, we'll start. You have sensors and actuators which bridge the digital and physical connection. Suppose you have, say, a speedometer in a vehicle. It can be an analog speedometer. Depending upon the spring tension, it will show you the speed of the vehicle. That is, however, not recorded. Suppose you want to know, okay, how fast did I go or how slow did I go? You cannot know. You will not know because it's not being recorded. In the same way, if you have a digital speed sensor, you will know how fast you went because it will record. Why will it record? Because it will use that speed sensor data for some other purpose, like, say, cruise control or emergency braking. So since you have a sensor sensing all the data which is being gathered, you can use that data to analyze and also make something useful out of that data, say for improving your ABS system or improving the ride and handling of your vehicle. Moving further, we have systems and internal services. You might have, say, an auditing platform, or what do you call it? You have a system check, a diagnostic check, which happens throughout the day. You can automate it, or you can see when the issues come up and do run it by a case by case basis, and finally decide when you have to run an automatic diagnostic on the system. So that can be automated. Finally, you must have connectivity between all your systems. So unless each system talks to one another, you will not the one system will not know what the other is doing. Suppose your car is your same production line. Your car is in the front of the production line where all the components are being manufactured. They are being cast in the casting machine in a blast furnace, and then they are moving on to the machining side, wherein certain parts have to be cut, say in the riser has to be cut. Finally, it moves to machining, wherein the finished the finished product is sent to paint and then to dispatch. Suppose some issue happens in paint, the paint line stops. So you can't have casting, machining, and the furnace casting and machining keep on running because it cannot go to paint. There will be a blockade. So when one system is shut down completely, the other system should know that after that particular cycle is over, they have to switch off until and unless the system is clear and you have a green signal to go ahead. So this is why connectivity plays a major role. Finally, you want to add a new line to your company, a new system. So the same new service and the new system has to coexist with the other ones and also come into this sort of Industry 4.0 scenario. Now, what are the benefits of Industry 4.0? We've been talking a lot about what Industry 4.0 is, how do you implement it, what are the components. What will be the benefit? Now, productivity, flexibility, quality, and speed. You will have increased productivity through higher level of automation. A majority of the projects you see at the company, the improvement projects, will be reduction of cycle time. Why is cycle time so important? The lesser the cycle time is, the more products you can produce in a day or in a given shift. So using Industry 4.0, you can might as well reduce the cycle time and improve your productivity. But you should be very careful. Reduction of cycle time does not mean compromising on quality or accuracy. You must have an accurate and perfect quality, not perfect, you could say, uh, as to specification level quality product while reducing cycle time. So all this is not only in the process, in the production line. You have to transport your material from a shed to the production line, and then it is inspected, and then it is sent into the first stage of the production line. So Industry 4.0 covers the entire cycle, not only the production line, it covers the place where it is raw material is stored, the place where it is inspected, and it comes to the production line and finally dispatched to the customer. So this is how you can improve your productivity. Next would be improving your flexibility. Okay, suppose you are a gear manufacturer. You make gears for gearboxes for cars. Where else are gears found? Gears are found in differentials, gears are found in reduction gearboxes, gears are found everywhere. So suppose you want to make a huge gear for a ship. You want to install a new production line, line B to your line A. Through Industry 4.0 and robots and machines which can execute the production process for a wide range of products and processes, you can achieve high flexibility in the process. And as I said previously, your reduction in cycle time should not affect your quality. So quality can be improved because you're checking every stage of the process. Just because, uh, not just because you can, You're supposed to, because there should be absolutely no compromise on quality. So suppose there is an error in quality, you can shut down the whole line and cross check, backtrack and check whether all your products are as per spec or were as per specification or not. Finally, speed. Speed is improved. You have an increased speed from the very first product, which is in the start of the day, to the very last product at the very end of the day. Plus, you don't need, suppose if it's a new product, you don't need to manufacture it and check. You can simulate what the product might look like in the production line and check. And you can directly send it out to mass production. And coming to the benefits of the workers, you can improve their occupational safety through increased automation. This is a very, very high topic which is being debated. Environment, health, and safety is very important. Just because a person comes to work at the factory doesn't mean you can subject him or her to unsafe working conditions. They, excuse me. They must be able to perform their job very well and very safe. Your working conditions can be improved. More people can be trained at Industry 4.0, and everybody can, in their own way, collaborate on the whole process of improvement. Finally, you will also be improving the environment. You will not be polluting the environment through harmful gases, polluting the water body. And finally, your innovation will improve.